This slide reinforces what has been discussed thus far. OLTP systems, or online transaction processing systems, aka operational systems, are optimized for efficient transaction processing through a spider web of normalized relational tables. The queries against OLTP systems are well known, predictable, and, after all complex joins are made, often touch just a handful of rows related to a particular invoice received from a particular vendor or a particular ATM withdrawal made by a particular customer. On the other hand, OLAP, or OLAP systems, which stands for Online Analytical Processing, are designed for efficient processing of complex queries on a relatively simple cube design, such as the one shown here, where a measure of interest, such as sales volume, is directly connected through a single join with each of dimensions such as product, time, and customer. Asking questions such as the ones shown at the bottom of the slide, and using the answer to support strategic decision making is surprisingly easy. There is no predefined path through such an analysis. A question answered often leads to another question, followed by another ad hoc and followed by another in an ad hoc and unpredictable pattern, leading us closer to the knowledge that will help improve strategic decision making. This slide presents a slightly more technical comparison between the operational versus analytics systems. OLTP systems hold mostly current values and back up the historical data periodically. OLAP systems need the historical data for trend analysis and summarize data for quick answers to some of the more standard questions that emerge over time. OLTP systems, as we stated a number of times by now, are designed for efficient transaction processing, whereas OLAP systems are designed for efficient processing of complex queries. OLTP creates a ton of data, but does not permanently store as much. OLAP does not create data at all, but stores as much as it can get its hands on. OLTP systems are always on. They use virtually 24/7. OLAP systems are periodically updated with properly cleansed and transformed operational data, often in batch mode during low usage periods. OLTP systems are primarily used to record business transactions, so they are insert, update, and delete heavy. OLAP systems are, by contrast, read-only. We only want to retrieve a subset of data to perform analysis on. OLTP systems have a fairly predictable, repetitive usage, such as receiving an order or processing an invoice. OLAP systems are used in a far less predictable, more ad hoc sense, depending on where the analysis is heading. Because OLTP systems are optimized for fast transaction processing, the response times appear instantaneous. You can click to submit an order and it is received in an instant. OLAP systems retrieving millions of rows or several years worth of data typically take longer, sometimes on an order of a few minutes, as we'll see even with our simple data warehouse with our in-class project. Finally, operational workers, clerks, salespeople, tellers are the primary users of OLTP systems. Knowledge workers, such as executives, managers, business analysts, etc., are the primary users of OLAP systems. In general, when you think of OLAP systems, think of OLTP systems, think of a spider web of hundreds of tables linked together, where queries are mostly of insert, update, and delete type. And, although they may affect dozens of tables at one time, they only impact a few records at a time. In other words, they're kind of shallow, wide and shallow. When you think of OLAP systems, on the other hand, think of a simple cube, it could be more than 3D of course, where the links between the information of interest and attributes surrounding it are direct and simple. The queries are always read-only and may affect several tables. The links, however, are always direct between the measure fact table that we'll define later on and the attribute dimension tables, so there are no complex joins or overly complex joins to execute. On the other hand, the number of rows retrieved is potentially huge, in millions or even billions, which is where the slower response time come from. And this is a good place to